Hey everyone, so in this video I'm going to go over solving radical equations level 2. And the thing that's going to be different here is that these equations will have two radicals to start with, and you're going to have to eliminate both of them. So that's the challenge here. So hopefully you were able to do the do now. If you weren't, I suggest you take the time to do it now and then press play. Okay, so the first step with a radical equation is to isolate the radical. So I'm going to do that by subtracting x over in this problem. And then once you do that, you square both sides so that you can cancel this out and you'll end up getting x. This you're going to have to do out twice because it's a binomial. We're not going to distribute the squared. We're going to write it out twice and do this properly and use box method. You get 36 minus 6x minus 6x and then positive x squared. These will cancel. This will combine to a negative 12. So I'll end up getting x squared minus 12x plus 36 equals x. If you remember from the last video, x squared likes to equal 0, so I'll subtract the x here. I'll cancel this out to 0, and then you'll end up getting over here x squared minus 13x plus 36 equals 0. And you're going to say to yourself, what are the factors of 36 that add to 13? Because you're going to do AM here. And the answer would be 9 and 4. You're going to get x equals 9 and x equals 4, and you're going to check your answer. And you're going to do that by putting this into y1 and this into y2 and looking at the table, and you are going to see that 9 will not work. The y1 and y2 don't match. So you're going to reject that answer and you're going to have just 4. Okay. Same thing with the other one. Isolate the radical, subtract the 1 over. You're going to get 3x minus 1 equals 2 rad x. Square both sides now. This will get you 4x. And just like the last problem, you're going to write this out twice because you're not going to make the mistake of distributing the squared. And you're going to box method. So you're going to end up getting 9x squared minus 3x plus 1. These will combine to a negative 6x. So I'll get 9x squared, negative 6x plus 1 equals 4x. Okay, subtract the 4x over, and you will end up getting 9x squared minus 10x plus 1 equals 0. Now you're going to factor. And look at this excitingness, guys. This is glasses. Oh my goodness, I know you're super pumped. So that 9 times 1 is 9. Factors of 9 that add to 10 are 9 and 1. You make them both negative to make a negative 10. So it'll be 9x squared minus 9x minus 1x plus 1. And you're going to factor this. You're going to pull out a 9 and be left with, a 9x, and be left with x minus 1. And then you're going to pull out a negative 1 and be left with x minus 1. And you're going to end up getting 9x minus 1 here, and then x minus 1 here equals 0. And you're going to solve for x. So you add 1 over, and you get x equals 1. Set this guy equal to 0. Add the 1 over. So 1 equals 9x, and then you'll divide by 9. You'll get x equals 1/9, and you're going to check this. The calculator trick with the y1 and y2 will work for this one. You'll find out that this guy works. And then for the 1/9, though, you're going to have to just plug in, like old school, plug in x as 1/9 and see if you can get the left side and the right side equal. You will not. It will not work. What I mean by that is I would plug 1/9 in here and 1/9 in here. And then I would plug it in and I would see that the left and the right side do not match. So you're going to reject that one and the answer would just be 1. Okay, So what's the first step you do to solve these equations? The answer would be isolate the radical. Okay, now here we go. We got two radicals, people. So the first step here is to separate the radicals. I always move the smaller one over to the other side. It doesn't really matter, but it's just easier to deal with the smaller one on the other side. And then it's the same process. So step one is going to be to separate radicals to either side. And it's the same process, solve. So you're going to square both sides. These will cancel. You'll end up getting x plus 3 equals, this is box method. There's a squared there. So you're going to have to write this out twice and go ahead. Okay, so 3 times 3 is 9. 3 times negative 1 radical x is negative 3 radical x. Same thing here. And then positive x, because remember, a square root times itself just comes out as itself. But if you don't remember that, I will just do it out for you because I'm nervous that you don't remember that. And negative 1 times negative 1 is positive 1, so this is just 1. Square root of x times x is x squared. But you should remember that x squared is just x, so that's what I was talking about. So this is really just x, because they cancel each other out, squared and a radical. You end up getting x plus 3 equals 9 minus 6 square root of x plus x, because this is going to combine. Let me move my work over here. Okay, so if you notice, it just transforms into a single radical problem to deal with. We've been dealing with this whole time. So you're going to isolate now this radical here. So I'm going to bring over the negative x, cancel, just happens to cancel out there, that's fabulous, and bring over the negative 9, cancel. 3 minus 9 is negative 6. Now, you have options here. You can either go ahead and divide by negative 6, or you can square both sides and then divide. It's really up to you because there's a multiplication symbol in between the two. I'll do a see it both ways because I would do both ways in class. The way 1, and then I'll do way 2 over here. So the divide by negative 6. These would cancel. This would cancel to 1. Square both sides to cancel this out. You get 1 equals x. Second way would be to square both, because you can, because this is multiplication. This would become 36x. This would become 36. Divide by 36. These both cancel out to 1 equals x. So they get the same answer. It's really whatever way you prefer. Again, you can only do this trick when there's multiplication in between. Okay, again, you're going to check your answer for any extraneous solutions. And you're going to do that by that y1, y2 trick. That's the easiest way I find it. Plug this into y1, plug this into y2, and see it with the table. And you will see that x equals 1 works. Okay, example 2. So you're going to bring over one of the radicals to the other side. I'll bring over the smaller one, so I'll bring over 3x plus 7. The difference really between the previous lesson and this lesson is that there are 2 radicals involved. Okay, and then you're going to square both sides. Nice here is that there's no parentheses around these, so what happens is the radicals actually cancel out, but you can distribute this in. So it gets you squared, squared. You're going to square this negative 1 technically and square this because you're distributing it in. 2 squared is 4, and then these cancel out. You'll end up getting x minus 8. Negative 1 squared is 1. I don't have to write that. These cancel out, so you get 3x plus 7. Distribute this in, you end up getting 4x minus 32. equals 3x plus 7, and then you're going to solve. So you're going to separate all the x's to one side. So I bring this guy over here, all the numbers to the other side. You end up getting x equals 39, and you're going to check. So you're going to check that 39 satisfies this equation. So I would type this into y1, this into y2, all the way down to 39, or you can just plug in 39 here and see if it equals 0. And you're going to find it does not work, and it's an extraneous solution, therefore it's no solution, because it's the only x we got. All right, am I done with this page? Yes. Okay, moving on. All right. We're going to go ahead and solve this guy. So I'm going to move over one of the radicals. It doesn't really matter which one here because they're both relatively the same size. You're going to square both sides. Square, square. This will cancel out because there's only a radical there. But here you have a negative sign in between. So unfortunately, we're going to have to box method this. Now this is very bizarre because it's, I don't know, it's just like weird because it has a binomial in it, and that kind of confuses you guys for some reason, but it's not a big deal. You're going to do 4 times 4 is 16. You're going to do 4 times negative 1 because that's what's in front of there, and then that radical just trails along. And the same thing here. This is negative 1 times 4 is negative 4 rad x minus 3. And then negative 1 times negative 1 is positive 1. And then a radical times itself is just itself. So it just pops right out. And that's where, especially for problems like this. Okay. So I'm going to end up getting, bring down this x plus 5. 16, these will combine to negative 8 rad x minus 3, because they're both of them are the same, plus x minus 3. I feel like I should have combined these to start, so I'm just going to do that now. 16 minus 3, yeah, that would make things a little bit easier. 16 minus 3 is 13. Yeah, okay. Like this radical right here. And I'm going to subtract the x over and add the, subtract the 13. These will cancel. You'll get negative 8 rad x minus 3. 13. Is negative 8. Okay, you're going to divide by negative 8 or square both sides. I really don't care what you guys do here. If you remember before I showed you guys 2 different ways. This will cancel out to 1. So I'm going to get 1 equals the square root of x minus 3. Then now you only have 1 square root, so you're going to square both sides. You'll get 1 equals x minus 3 because these guys cancel out. And then you're going to add 3 over, and you'll end up getting 4 equals x. You're going to check your answer, and you're going to find out that this guy works, and we can keep him. Oh, yes, this one here has the radicals already on either side, so we are super set to just go ahead and square both sides. Okay, squared, squared. These will cancel. You end up getting x plus 81, and then this guy over here, unfortunately, but fortunately, we have to do box method. I'm saying fortunately because at least it's a small radical. And I don't know where I got that extra 3 from, but we're going to fix that. Okay, 3 times 3 is 9, 3 rad x, 3 rad x, and then a radical times itself is just the inside, it's just the radicand. These guys combine, 9 plus 6 rad x plus x equals x plus 81. Awesome. Isolate this radical. Minus the x over. I love when they both cancel out. That makes my life so much easier. Minus 9, cancel out. Oh no. Okay. I hate when it does that. 6 rad x. Okay. 81 minus 9 is 72. Divide by 6. And then rad x, oops, equals 12. Square both sides so that you get rid of this radical, and then you end up getting x equals 144, and you're going to check that answer, and you're going to find out this answer works. Boom. What else do we got going on here? Another one. And look, it's a single radical one. It's a level 1. We can do this. We're going to get this one done. Okay, so level 1, the radical is by itself on its own side, so I can just go ahead and just square both sides. Cancel this out. Okay, this is going to box method into this. If you guys want to do the full box method out, you don't believe me, you can. X squared likes to equal 0, remember that. That's how you can factor it and solve. This gets you 10x, and this gets you 21. Factors of 21 that add to 10 are 7 and 3. You're going to set these both equal to 0. Oops. And you'll end up getting x equals negative 7 because you're going to subtract 7 over. And x equals negative 3. And you're going to check your answer, and you're going to find out that I don't believe negative 7 works. Let me pause this and figure it out. Yeah, no, negative 7 doesn't work when you guys check that answer. If you plug in negative 7 to the original or do the y1, y2 trick, you'll end up getting like 1 equals negative 1. That doesn't work. And then negative 3 does work, so your answer would just be negative 3. It says, explain why it's necessary to check the solutions of a radical equation. You want to look for extraneous solutions. This happens during the squaring step. Just so you guys know, when you square, you're doubling or squaring the problem, so you're resulting 2 answers and one of them might not work. So during the squaring step, extraneous solutions happen. They occur. I definitely spelled that wrong. Occur. And do not satisfy the original problem. This is basically because you'll get answers that give you a negative inside the radical or result in an answer that doesn't result in a negative. And remember that you can't get a negative out of a radical, but it all basically happens in the squaring step because you're multiplying the problem by itself, which creates extra answers. All right, well, I hope this helped you with level 2 and kind of level 1 because we had a little bit of a review on that. And if you need any extra help with it, come to extra help.